Can you type? I think exercise 6.2 I was doing with you, Abdullah. Okay, so 6.2 is actually over. I have started 6.3 now. So I just want to give you a brief introduction till Martin joins of exercise 6.3. See, basically, in the first exercise, Abdullah, we learned about the two conditions. See, if we want to show similarity in two triangles, right? So two conditions has to be satisfied. First of all, the angles has to be equal. And the second, the sides are to be in proportion, right? Understood? So these were the two conditions that needs to be satisfied if the two triangles are similar or any other figure. Okay, so 6.3 is basically starts with three theorems. The first theorem is, yes, Martin, have you joined? Okay. Anyway, the first theorem, Abdullah, is that in a triangle, yeah. So if all the angles are equal, right? If all the angles are equal, then the corresponding sides are in proportion. This theorem is already written in your NCERT book, so just try to understand, don't write. Corresponding sides are in proportion. So that's the theorem, all right? Now, it means that if all the angles are equal, so it is the theorem that the corresponding sides are going to be in proportion, and hence the triangles will be similar. Are similar. So understood. See, angles were already equal, right, Abdullah? Angles were equal. Then by theorem, the theorem says that if all the angles are equal, the corresponding sides are in proportion. So that means both the conditions are now satisfied. So the triangles will obviously be similar. And this criteria is called AAA criteria for similarity. All right. Or at least type yes or no something so that I can know you are here.
Okay, ma'am.
Okay. Martin, you are here?
Yeah.
Okay, so I was giving just a brief introduction to Abdullah, then I'm going to start the exercise.
Okay, ma'am.
Okay, so it's for your revision also, Martin.
Sure,
So
ma'am.
theorem one was that if all the angles are equal, then by theorem, the corresponding sides are in proportion. So basically two conditions are now satisfied and therefore the triangles are similar. So we call it AAA criteria. Then there is a second theorem. What was that, Martin? That if all the, all the sides are equal.
SSS.
Yeah, SSS. So all sides are equal. If all the sides are equal, then corresponding angles are also equal. So I'm writing in short, right? So all the angles will also be equal in the triangle. If all the sides are, sorry, not equal, I'm sorry, are in proportion. So ultimately, both the conditions are now satisfied, isn't it? The sides are already in proportion. So by the theorem, the angles will be equal. So condition one satisfied, condition two satisfied, and hence the triangles are similar. Understood? So this theorem is basically called SSS criteria for similarity. So try to understand this SSS is not SSS of congruency, Abdullah. In congruency, the sides were all equal, isn't it? Equal in length, but here they are in proportion. So understand the difference. Okay, and the third theorem was, Abdullah, theorem 2. Third theorem is basically if two angle, sorry, like one angle is equal in for example, there's a triangle here and another triangle. So statement is written in the book. I'm just explaining the meaning. So let's say this angle A is equal to angle P, right? So by the theorem says that if these two angles are equal, then the sides which are actually forming the angle, these two sides and these two sides will be in proportion. All right. So BC and QR. So if angles are equal, so ultimately this means that AB by PQ will be equal to AC by PR. So these two sides, like between the sides where angle is formed, so only these two sides. Do not take this one. Sometimes in question, this one is given just to confuse you. So we look at these sides only. Understood? So these are in proportion. So this criteria is called SAS criteria, where two sides are in proportion and one angle is equal. So these are the three criteria which we use to prove similarity in triangles. And this AAA sometimes is also reduced to AA criteria only, because we know if one triangle, right, two angles are equal, the third one is obviously equal because the sum of the angle is 180 degrees, isn't it? The third one will obviously be equal. So sometimes in
Yeah.
question it might happen that if two are equal, then by two also we can say the triangles are similar. And if the third one is very clearly visible that it is equal, so we can write there is no problem, then we call it AAA criteria. Understood? Okay. So that's the first thing, Abdullah, we did. And yeah, just one thing, how to name triangles, similarity. For example, I have a triangle ABC, right? Okay, let me use the next slide now. Martin, how many questions we did from 6.3?
We already did the first question, like first
Oh,
question, all sub questions.
okay. Okay, only first we have done. All right.
6.3, right? Yeah.
Yeah, okay. Yeah, you have sent me pics also. Just wait. So just one more revision. Let's say these two triangles are similar. Okay. Uh, ABC and PQR. Right, Abdullah? Now, or let me call it like this. Just a minute. All right, Abdullah. So these are the two triangles. Okay. Now I'm saying, okay, I'm saying angle P is equal to angle A is equal to angle P. And okay, in this triangle, angle B is equal to angle R, let's say, and angle C is equal to angle Q. So how will I write that they are similar? For example, in congruency, it is important, the sequence is important, right? Similarly here. So I cannot write that triangle ABC is similar to triangle PQR. No, it will be wrong. Okay, Abdullah? The correct thing is triangle ABC. Now, A is actually equal to angle P. So I'll start with P here, all right? Then angle B is actually equal to angle R. So it will be R here and then the third one, Q. So that's the correct way of writing. Understood? Okay. So that's one thing. Now for the same triangle, if I say that, let's say AB, okay, if I say that triangle, for example, CBA is similar to triangle RQP. All right. So which side is proportion to which side? How will I write? Yes, Abdullah, please see here. So if it is written CBA is similar to RQP, so which side is proportion to which side? Now how to see? So you like see here. So CB will be proportion to RQ. So we write CB divided by RQ. Understood? And then this BA will be in proportion to QP. So BA divided by QP. All right. And then the third one. So the last is CA upon this RP. Understood? So that's the way of, so that means this CB side is actually proportion to this RQ in the figure. Got it? Okay, so let's come to the exercise now. So these are few things you need to understand. Okay, Martin, so question number 1, I asked you to finish. So is there any problem in the question?
No.
Okay, I'll just go through your pictures again. I didn't get the time now. Let's start with question number 2. So in the given figure, triangle ODC is similar to triangle OBA. So please like see your book, both of you. This is something like this. So DC and AB, right? This angle is 125 degree. This angle is 70 degree. Okay. Now these two triangles are similar. So triangle ODC is similar to triangle OBA. Okay. And find angle DOC. Okay, this is O. DOC means this angle you have to find, right? This one, green. DCO. So DCO, this one. And OAB. OAB, that means this one. Okay, so let me call them something X, Y, and Z. So who will tell me the values of X, Y, Z in this question? It's very easy. Please try to answer me.
X is 55.
How you got X?
Ma'am, I subtracted 125 from 180.
Yeah, very good. So actually angle, X plus 125 is actually equal to 180 degree, right? Linear pair.
Yeah.
Okay, that's good. So angle X will be 180 minus 125. So it will be 55. That's good. Okay, what about Y and Z now?
70 plus 55 plus y equal to
Okay, very
1.
good. Very good. So angle X plus 70 and plus angle Y is equal to 180 degree. What's the property? Name of the property, Abdullah? Yeah, Abdullah will type now. Yes, come on, Abdullah. Type it quickly. What is the name of this property which I'm using here? Okay, in triangle DOC, basically I'm using angle X plus 70 plus angle Y is equal to 180 degree. What we call it? Angle sum property, isn't it? That the sum of all the angles of a triangle is 180 degree. All right. So from here, what is the value of Y, Martin?
Y is 55.
Yes, it's 55. That's good. Okay, so X and Y we have got. Now what about Z? How will I find it?
Ma'am, wait.
Hmm. See, if it was given in the question that DC is parallel to AB, then it was so simple that angle Y is equal to angle Z, alternate interior angles, right? But, this thing is not given. Something else is given. Make use of it. Yeah, come on. You always have to make use of the given conditions. That is why it is given. Okay. Now, see here. Now, this triangle ODC. So when you get stuck, so I mean that's a tip. I mean, just clear, very clear. Look at the given condition, so you will find the clue here. Now, these two
Oh,
triangles are similar, so the corresponding angles are equal, isn't it?
yeah.
So make use of it. So
Dot
ODC.
angle D equal to angle.
Yeah. So C will be equal to A, isn't it?
Yeah.
According to the naming of the triangle. So basically angle D is equal to angle B here. And then angle C is actually equal to angle A. That's how it is named. OO is, actually that's not the correct way of naming. You write it like this. ODC is equal to angle OBA, right? And angle C is equal to angle A. So DCO is equal to angle OAB. So this is actually your Z, right? OAB. That means angle Y is equal to angle Z. So what is the value of angle Z? Again, 55 degree because Y is 55. Okay. Yes, written. Next question. So diagonal AC and BD of a trapezium ABCD. So that's the trapezium ABCD. Okay, and draw the diagonals. O. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC. So something is given here that AB is parallel to DC. Obviously, it's a trapezium, so one pair of opposite sides will be parallel here. Intersect each other at point O. Using a similarity criterion for two triangles, show that, so to show that OA upon OC is equal to OB upon OD. Okay. Hmm. So Martin, see here, which is OA. So OA is this and OC is this, right? Okay, and
Uh,
OB is this and OD is this.
okay.
And also written in the question that by similarity criterion, you have to show this. So if we somehow show that these two triangles are similar, so corresponding parts, our sides will be in proportion. Understood?
Yeah.
Yeah. So let us try to look into these two triangles. What we can do here. So
Just like make
mhm.
like a construction.
Construction will not be required because you have to use similarity criteria now, not BPT. Understood? So in triangle, let's say AOB and triangle COD. So let us try to look at AAA criteria if we can do it. So look here, it's clearly written that AB is parallel to DC, right? These two sides are parallel. So this angle will be equal to this angle, isn't it?
Yeah.
Yes, Abdullah. Angle 2 is equal to angle 1. Which kind of angle? Alternate interiors, isn't it?
Yeah.
Alternate interior angles. Okay. And again, this angle 3 will be equal to angle 4, isn't it? Angle 4 is equal to angle 3, because AOB this side. So I'm writing this angle this side. Same alternate interior angles. What about the third one? From here by
Uh,
AA criteria also we can say, but in this figure, actually this angle is also equal to this angle, vertically opposite, right?
yeah.
Yeah. So it's your wish, you want to write, you write. Otherwise, by AA criteria, these two triangles are similar. So triangle AOB. Now very carefully, what should I write here? Sorry, not equal, similar. How to name it? Now see, 2 is actually equal to 1, right?
Yeah.
So this side, like C, I have to write here. And then obviously O is O and D is, this angle is actually equal to this one. So I'll write D here. So that way. Clear? Okay, so
Yeah.
now they are similar. So therefore, or this implies that OA upon OC is equal to OB upon OD, corresponding sides of similar triangle. You can write
See.
corresponding sides of,
Okay. So what theorem did you use to prove that OA by OC?
wait. Yeah, what are you saying?
It's how
Yeah,
did you do it?
as we use CPCT for congruency, isn't it? That if two triangles
Yeah.
are congruent, then by CPCT, all the sides are equal in length, right? So same way, the triangles are similar. Because the triangles are similar, so obviously the sides are in proportion. That's why they are similar, isn't it?
Okay.
So the reverse thing we are writing. So don't write CPCT, it was for congruency, congruent part of congruent triangles. Here we write corresponding sides of similar triangle or corresponding angles of similar triangle, that way. So have you written?
Yeah.
Okay. Next question now. In given figure, okay, it's a good question and very easy. So please look at the figure in your book, something like this. And then there's a line here, and then there is a line here. Okay. This is Q, P, T, R, S. Okay. So in the given figure, this is given that given QR upon QS, okay, is equal to QT upon PR. So, two sides are in proportion. Now you have to actually see which triangle is he talking about. And angle 1 is equal to angle 2. So this is angle 2, this much, and this is angle 1. Okay. And angle 1 is equal to angle 2. You have to show that triangle PQS is similar to triangle TQR. Okay, PQS is where PQS, okay. So see in the figure PQS and TQR, that means the complete one. So understood the figure?
Yeah.
Okay. Now we start with the given condition first of all. So let's do the proof here. It is actually given that QR upon QS. Now where is QR and where is QS in the figure? QR is actually the complete side here, right? And QS is, okay, this short one. So basically this
Okay.
complete side and this, they are in proportion. So which triangle I have to take? It is very clear from here.
PQR.
PQR and the other one.
QTR.
No, no, no. See this side. This side is part of which triangle? QS.
Yeah, PQS.
PQS. Yeah. So got the clue from here, right?
Okay.
Okay. So
Yeah.
basically we have to take these two triangles, like this one whose side is this, and the other this one whose side is this.
Okay.
Okay. So one angle is given equal, okay, and yeah, we can do one thing here because angle 1 is equal to angle 2, right? So that means
Yeah.
this side is equal to this side.
Okay.
Why?
Because given
No. From
PQ
here,
equal to PR.
in any triangle, if these two sides are equal, then the opposite angles are also equal. Corresponding angles are also
Okay.
equal. Yeah, that's the theorem.
Yeah.
Previous ninth class you studied about it.
Okay. Okay.
Yeah. So the sides opposite to equal sides are also equal. So therefore, like angles are equal, so sides are equal, and sides are equal to angles are equal. So that's the theorem for class 9th. So angle 1 is actually equal to angle 2. So that means this side is equal to this side, right? So QP is equal to PR. That's something we got from here. You can write sides opposite to equal angles. Okay. So we will change our given condition from with the help of this. So it is given that QR upon QS is equal to QT upon PR, right? It is given. So can I change it like this? QR upon QS, okay, is equal to QT. And now in place of PR, I'm writing this PQ. Got it? So I'm making use of this result. Why? Because ultimately I have to show that TQR, right? I have to include the complete angle TQR. So sides I need in proportion. Now you see which side is this. So Martin, see here, QR upon QS. That means this QR, right? And upon this QS. Understood?
Okay.
Okay. Now QT upon PQ. So QT is this complete side and PQ is this complete side. So which triangles I have to take now? Obviously these which I have to show similar. So let's start here. So in triangle PQS and triangle TQR. Okay. So I have got QR upon QS is equal to QT upon PQ. Okay. And angle 1 is equal to angle 1, which is common. It's a part of both the triangles, right?
Yeah, ma'am.
So I'm actually taking this triangle now, the small one, this one, and the complete. Understood?
Okay,
PQS
ma'am.
and TQR. Okay, so angle 1 is a part of both the triangles, so it is common. And sides are in proportion from here I have got, right? So how will I write that triangle PQS is similar to triangle? Now see here, uh, if I'm taking just a minute, how to name it, TQ, yeah. So see here, if I'm writing PQ this side, so I have to take this QT here, right?
Yeah, ma'am.
And also be careful about the angles because angle Q is this, so it has to be in middle. So I'll write T and Q because Q is here, so Q has to be here, right? And then R,
Okay,
TQR,
ma'am.
so that way.
Okay.
Abdullah, any problem in this question? So written, Martin, I hope you have written.
Yeah.
Let's do the next one. Fifth. S and T are points on side. Okay, that's the figure.
Angle 1 equal to angle 2, right? Or angle 1.
Angle 1 is equal to angle 1 because that's a common
Oh,
angle, right?
okay.
Yeah, see here. It is part of both the triangles, right? The small one also, the bigger one also.
Okay, ma'am.
Okay. Right, next question, fifth. Okay, S and T are points on side PR and QR, all right, such that angle P is equal to angle RTS. That means this angle P is equal to RTS, this angle, right? No, am I right?
Yeah, ma'am.
RTS. Okay, show that. So it is given that angle P is equal to angle RTS. Okay, to show the triangle RPQ, okay, is similar to triangle RTS. Okay. Okay, let's do the proof. So let's take these two triangles and see which criteria we can satisfy. So in triangle RPQ and triangle RTS. So Martin, tell me which something I can write here. So one thing is given that angle P is equal to angle RTS. So one angle is given. What else I can write here? First of all, see which triangle I'm taking.
Okay.
RPQ is which triangle?
RPQ is the whole triangle.
Whole. Okay. And RTS, the small one.
Yeah.
Okay. So can you see something common here?
R.
R. So angle R is equal to angle R. So two angles are equal. So AA criteria I can use. This is common. This was given, right? Only two angles are sufficient to prove. So by AA criteria, these two triangles are similar. So RPQ will be similar to triangle RTS. So just check the naming also, because R first, right? R is equal to R. Okay, then angle P is actually equal to where angle T is. So that's the correct naming. Okay, please note it down. I'm drawing the next figure here.
Okay, I'm done.
All right, let's do the next one. Yeah, there's an announcement I forgot to tell you on Thursday, right? Next class.
Okay.
You will have a test. And can I take test of triangles? Like up to where we have done?
Okay, ma'am. Ma'am, can you take coordinate geometry also? Like, what do you call it? The lesson?
Yeah, because you have exam, right?
Yeah.
Oh, okay. So I think next class I'll not take test, then I'll start coordinate geometry.
Okay, ma'am.
26 you have your test. So after your exam, I'll take a test.
28, ma'am, 28.
28, fine. So perhaps in the after that, next class, let's see.
Okay.
Okay. So fifth question now. Sixth basically. Yeah. Now see, in the given figure, if triangle, okay, so something is congruent here. So it is given that triangle ABE. So clearly see which is ABE in the figure, and ACD, they are congruent, okay? To show that triangle ADE is similar to triangle ABC. Okay. So let's see which is ADE. ADE is the top one, right? ADE. And ABC the complete one. Understood?
Yeah.
So angle A is a part of both, very clearly visible. Yes, Abdullah? ADE and ABC. A is there in the both, you can see, right? A. So angle A is common here, right? One angle we have got. Ultimately, see how many criteria do I have, Martin? It's similarity is actually easy. I only have AA or AAA.
Yeah.
That's the same thing, right?
Okay.
Okay. Then I have SAS, where only one angle is equal and then two sides needs to be equal, and then SSS. So that's the only thing. Now already I've got one angle equal, so this is already ruled out, right?
Sure. Okay.
So now I have to see what I can do from here. Either I will try to find another equal angle, or I'll try to find two sides which are actually in proportion, right?
Yeah, ma'am.
So that's how you approach the question. So now make use of the given condition. So something is given here, proof. Now which triangle is ABE? See, ABE is actually congruent to triangle ACD. So is it visible in the figure which is ABE
Yeah.
and ACD, right? So I can use
Okay.
CPCT, correct?
Yeah.
So by CPCT, what should I write here? See, by CPCT,
By
the side,
CPCT,
yeah,
um,
BA is equal to AC, correct?
yeah.
So this I can write that BA upon AC is actually equal to 1. Can I write it like this?
Yeah.
Right?
Okay.
Okay. And other side, I can write that AD is equal to AE. Can I write it?
Yeah.
So again, this I can write that AD upon AE is equal to 1. Clear?
Sure. Yeah.
Okay, so now I can just compare these two.
So then BA upon AC equal to AD upon
Yeah, so BA upon AC will be equal to AD upon AE. So two sides I have got in proportion. So that means which criteria I'm going to use? SAS, right?
Okay.
Yeah. So because it was difficult to find another angle without any clue, nothing else was given, so I did this. Anyway, now which is BA upon AC? See in the figure, BA upon AC is equal to AD upon AE. So it's now so easy. So in triangle ADE, so take the triangle which you have to show to be similar and triangle ABC. So this I have proved because ADE I'm writing first. So I write AD upon AE is equal to BA upon AC, right?
Yeah.
This is actually proved. And angle A is common. So which criteria? So therefore
SS.
SAS, yeah, by SAS criteria.
Ma'am, you already have one angle here.
SAS, because I'm
Oh.
using. So two sides I need in proportion and only one angle has to be
Uh,
equal. So angle A is equal to angle A, right? Common
yeah.
part of both. So triangle ADE is similar to triangle ABC. So please check the name. So AA first, right? Okay. And then you are getting AD upon AE. So it should be AD and, oh, wait. Oh, some mistake I have done. I have to rearrange it, isn't it?
It's ADE. Hmm.
Just a minute. Nothing. Wait. You can just make it like this. You bring this BA here because that's how we AD upon AB is equal to AE upon AC. Is this fine now? Because I'm taking two triangle ADE and ABC. So look in the figure. So actually this side should be in proportion to this side, right? And this side
Yeah.
should be in proportion to this side, right?
Okay.
So I've just rearranged it. So now I have AD will be in
Wait,
proportion
why
to
should we do
AB
like that?
because that's how we name it, right? No, if we do it right, Martin, for example, I have one triangle. So let's break this triangle. So this is my small triangle ADE, right? And
Okay,
that's my
ma'am.
bigger triangle ABC. So if they are similar, so it means that the side
Oh,
of one upon the side of other is actually,
so
in
you assume that
proportion to
both their
AE.
sides are equal.
Yeah, so that's how we write the proportionality, right? That this side is in proportion to this one, and then this side is in proportion to this one.
Oh, okay.
Yeah, that's how we write it. So that's why. So actually, these two were actually of the same triangle. So I've just rearranged it. So I have brought AB here and AE here, just uh, right. Any confusion? So tell me now. And that's how we
Mm,
name Martin. Because if I call ADE similar to ABC, so that means AD has to be in proportion to AB, right? So if I'm writing AD here, so I must have AD upon AB. Then only I'll write AD is proportion to AB, correct?
yeah.
So just that's why I've just brought AB here. Abdullah, any confusion? Okay. Yeah, Martin, if you have any confusion, just tell me right now.
Okay, ma'am.
I hope it's clear, right?
I'm writing this.
Yes, you write it. Written.
Yeah, ma'am.
Okay, any confusion at this step, Martin, again?
No, just two sides. It's just had to prove.
Okay, just again, see here. If I have two triangles, Martin, just go back to exercise number 1, right? Let's say
Okay.
ABC is similar to PQR. So if they are similar, so that means the side of one is actually in proportion to the side of other. So that means AB by PQ, right, will be equal to BC by QR, will be equal to AC by PR. That's how I, right? If
Yeah.
ABC is similar to PQR.
Okay.
So if I take side of one, then I take side of other because I am proving the triangles to be similar. So side of this triangle is actually proportion to this one. Then this side will be in proportion to this one. This side will be in proportion to this one, isn't it?
Yeah, ma'am.
So AB of one triangle, then PQ of the other triangle. But here AD and AE were actually of the same triangle, the
Yeah,
top
ma'am.
one. So that's why I've just rearranged it. Understood? I hope
Okay.
it's clear. Okay, next question, number 7. So please see the figure in your book, both of you. Sorry, my finger is so bad. Just trying it again. Okay, let's start now. So in the given figure, altitudes AD and CE. What is an altitude? What does it mean? Yes, Abdullah. What is an altitude? Yeah, Martin.
Like height or something.
The perpendicular height, that word is
Oh,
important. So that means it is making an angle of 90 degree here, right? It's like it's a
yes,
straight
ma'am.
90-degree height. Okay. So altitude of triangle intersect each other at point P, show that. So these are altitudes. This much is given, right? So that means these angles are 90 degree. That is given. And to show, first, there are 4 parts. So first you take this triangle. AEP is similar to triangle CDP. Okay, this we have to show. Because altitude, that means angle, something related to angle is given, right? So let us try to look at these two criteria, AA or SAS. SSS, I think, will be ruled out here. Understood, Martin? So first let us try AA. It's very easy. So in these two triangles, look, AEP is which one? The small one, AEP. See the figure?
Yes, ma'am.
And CDP. Okay. So which angle is equal to which angle here? Tell me.
Um, P angle P equal to angle P.
Why?
Common.
Is it common? Common is like this. For example, I have a triangle here, and inside it I have another triangle. So if this angle is part of both the triangles, so then it is common, right?
Yeah.
Here, this angle is here and another angle is here. So is it common? No.
No.
Yes, Abdullah. You'd say something here. I mean, just look at the given condition, altitude. That means some angle is 90-degree here. Which
No.
angle is 90-degree in both the triangles?
E.
E, is this the correct way of writing? E. If you have an angle at the vertex, then it's okay. You write it E. Clear?
Or like
But here you cannot write it E.
C E B.
CEB. Okay. Yeah, okay. This is 90. That's fine. This is 90. It is clear. But Martin, see which triangle you are using. You are using AEP. So that means you need this triangle, which is with this angle, which is inside this triangle, right? Not the outside triangle angle. Clear?
Yeah.
Yes. Okay, see again, because I'm using triangle AEP, this triangle I'm using AEP. So I need an angle which is inside it, not the outside one. So if this angle is 90-degree, then obviously this is also 90, isn't it? Linear pair.
Yeah. Angle
So that means angle AEP is equal to 90. And which is the 90 angle in the other one?
PDC.
PDC. That's okay. So both 90-degree.
Okay.
So one angle is 90. What about the other one?
Can we take like APE equal to CPE?
CPD.
CPD?
Why?
Like both of them have like opposite angles.
Vertically opposite angle,
Yeah.
yes, is equal to angle CPD. Okay, they are called vertically opposite. When you have intersecting lines, so whenever you have an X forming, so this angle is equal to this angle is equal to this, right? They are called vertically opposite. So AA criteria is fulfilled here. So these two triangles, that AEP, similar to triangle CDP, AA criteria, right? So see, here, D here. So 90-degree, 90-degree. So that's the correct way of naming. P here, P here. Second part, what you have to do, triangle ABD similar to triangle CBE. So I hope you have written, Martin. All right, now look at what is ABD in the figure. Can you spot ABD
Yeah, ma'am.
and CBE?
Okay.
Or CBE and ADB. So first of all, C cleared.
Okay.
Now tell me which angles are equal.
Angle B equal to angle B.
Okay, that's good. It is common. Okay, what else? Again, one angle is
Angle
90
D equal
degree.
to angle E, 90 degree. Now might come ADB equal to CEB.
Okay, that's good. So ADB is equal to angle CEB, 90 degree. Okay. So AA is fulfilled. So these two triangles are similar by AA criteria. Just, I mean, check the names, okay? ABD, because BB in between, right? Then D corresponding with E, so it is correct. Okay, so now you spot what is AEP in the figure. It's similar to ADB. Yes, Martin. Written so far?
Yeah, ma'am.
Okay. So now take these two triangles, AEP and triangle ADB. Okay. Now tell me which angle is equal to which angle here. Yes, Abdullah, you can also type your response. Martin, when you see the name, you are having
Yeah.
A here. Again, you are
Angle
having
A
A
equal to
here.
angle A.
So should I write angle A? Because angle A is the complete
Oh
angle.
yeah.
Yeah. I
Yeah,
write
you should
angle
write.
PAE, right? Because only this much angle I'm taking, not the complete angle A, correct?
Oh. Okay.
Okay, now ADB. So it should be which angle? Yes.
Yeah. Wait, taking the angle part, ADB and AEP are like, they both are in like the same.
Yes, 90 degree, right? This angle is also 90 and then
No, ma'am,
A.
no. The ADB and APE, they both are in the same
Yeah, because
angle,
this
right?
angle is common, right?
Yeah.
See, I cannot write angle A here because A is complete one. So complete angle is not
Oh,
equal,
okay.
right? That is why. Getting it?
Yes, ma'am, we can just take
Yeah, so I'm just naming it.
AEP equal to
Hmm.
ADB.
AEP. Yeah, okay, that's good. AEP is equal to angle ADB, right? So this angle is equal to this one, right? 90 degree.
Yeah.
This is common. Common means you have this part is common, right? Okay, so they are similar. So you can write triangle AEP is similar to triangle ADB. Yes, Abdullah, you can also type something here. Which angle you see equal here this time? First of all, spot these two triangles in the figure. Which triangle I'm talking about? You cannot answer. I hope you are able to understand, Abdullah. Yes, it's okay. If it is audio problem, then it's okay. Okay, fine. Please look into your audio settings, Abdullah. It's for your own benefit, right? All right. So Martin, in triangle PDC, now where is PDC and BEC?
Ma'am,
Hmm.
the PDC is in top and
Hmm.
BEC is below in the
Okay, fine.
first.
So now tell me PDC, that means this angle I need. And
So you can take
BEC,
angle P,
yes, angle D. So I'll name it angle PDC is equal to angle, which angle?
PEB,
Okay.
PEB.
Hmm. Take this CEB, right? Because I'm taking triangle BEC, right? So take the complete side. BEC, look here, which is BEC. So take side CE, CEB. That's how, right?
Yeah.
Don't use P here. Okay. Both are 90 degree. And what else?
Ma'am, angle C equal to angle C.
Common. Okay. So if you call it X, right? So angle X is equal to angle X, common,
Wait,
right?
so why are we taking angle X?
Because angle C is a complete angle, right?
Ah,
That's why I'm taking only this much part.
so we can also take PCD equal to
Yeah, that's how
ECD.
you can write. Yeah. So just to avoid the naming, I've called it X. No problem. You can write that. So
We
these
can
two
write
triangles.
ECB equal to PCD.
Okay, you want to write it like this. So angle. Mm, oh, okay. PC. See this triangle PDC. PDC. So that means angle PCD. Okay, will be equal to angle. Now BEC means angle ECB, right?
Yeah, ma'am.
So these two triangles are similar by AA criteria. So, okay, I think time is over now. So we will continue with triangles in the next class also, Martin, and I hope you will complete the exercise. And then I think one or two class more we will get before your exam. Coordinate geometry I'll finish.
Okay,
Okay.
ma'am.
Or I'll arrange a special class. Don't worry if something will be
Okay,
remaining. So I'll take some extra class for you. Okay.
okay.
All right then. Bye. Okay, Abdullah. Bye.
Okay, thank you, ma'am.
Okay, bye. Thank you. Hello, Rida. Can you hear me?
Yes, ma'am.
Okay. So, Rida, have you completed triangles?
Yes, ma'am.
Okay. So, Rida, one chapter, quadratic equation, I skipped in between. So, should I do it now?
You want?
Yeah. Sorry, I didn't hear, Rida.
If you want to.
Okay. Actually, Hamna is not joining right. Let's wait for 1 or 2 minutes more for Hamna. So, because you have already done that, I think for your exam, you have completed quadratic equation. Yes, Rida.
Yes, ma'am.
So, were you having any problem in that chapter?
My teacher explained it.
Sorry, louder.
No, ma'am. My
No.
teacher explained it.
Okay, okay, fine. So, should I start with coordinate geometry now? I think, right?
Yeah, okay.
Just a minute. Okay, which chapter you are doing in your school right now?
I'm not doing anything right now.
Okay,
I
fine.
just have exams right now.
Okay, okay. So if you're having exams, so I think I should not start with a new chapter. Can I give you some practice questions then?
Yes, ma'am.
Okay, that will be good, I think, because Amna is also not here. Let me give you some questions from triangles. Okay, first one, this is a figure ABC and DE. Okay, so it is given in this figure that AD upon BD is equal to AE upon EC. Okay, and angle ADE is 70 degree, angle BAC is 50 degree, and you have to find angle BCA. So can you find it?
Okay, ma'am. Ma'am, 60 degree.
Yes, okay, that's good. Okay, let's do this question now. Just a minute. Okay, tell me this one. Let's do some questions from quadratic equation. For what value of k? The roots of the equation x square plus 4x plus k is equal to 0 are real.
Ma'am, can you explain?
Okay, see, basically for real roots, what is the condition? If the roots are real, so that means your determinant is greater or equal to 0. Clear?
Yes.
So you find the determinant here. What is d equal to? D is b square minus 4ac, right?
Yes.
Okay. So what is b here? That means 4 whole square and minus 4 into a is 1 and c is how much? K. So this is 16 minus 4k. So for real roots, this 16 minus 4k should be greater or equal to 0, right?
Yes.
So 16 should be greater or equal to 4k. That's how we do it. Or then 4 will be in division. That means 4 will be greater or equal to k, or we write it k is smaller or equal to 4. So this, for this value, if k is smaller or equal to 4, then this equation will have real roots. That's how we do it. Okay. Okay, this is a previous year question I'm giving you from the triangles only. So do this type of questions also from quadratic equations, right? So have you done this kind of questions? Oh, actually, some exercise are deleted, right, Rita, from quadratic equation?
Yes.
Oh, okay.
First one is deleted and last one, I think.
Oh, okay. This question was from the last one. Okay, then it's fine. Just forgot. Okay, this question I'm giving you here. Triangles, which is M, K, and L, right? And this side is P and N. So this is given that this angle is 46 degree. This angle is also 46 degree, right? And this side is B, this much. And this is C from here to here. This is A. And this side is X, right? From here to here. So you have to express X in terms of ABC. So can you do this one?
Yes, ma'am. Ma'am, X is equal to AC by B plus C.
AC by B plus C. Okay, that's fine. Correct. Okay, one more question I'm giving you is this one. These are all previously asked questions in the exams, right? So you have a triangle here and A, B, C, and this is D. Now something is given that AB is equal to AC and BC square is equal to AC into CD. This is given and you have to prove. So you will do it and send me the picture that BD is equal to BC. This you have to do. Yes, Rida, are you able to do?
Yes, ma'am.
Shall we do it together?
Ma'am, I'm done.
Okay. Okay, I'm just making a figure of the next question. You should try. This one you can send me. I'll just go through it.
Right now,
Yes, right now you can send if you can. Yes, Rida. So till then you try the next one. I'm just going through your picture.
Ma'am, in the figure you draw, where is E?
Yeah, the figure is this, right? And you can just name this point. Sorry, I just forgot to name it. This is E, right? So DB is actually perpendicular to BC. So that means the angles are 90-degree. It means this. DE is perpendicular to AB. So that means this angle is 90-degree. AC is perpendicular to BC. So this 90-degree. So this much information is given.
Okay, ma'am, I'm done.
Done. Okay, it's good. So Rida, like tell me, would you like to continue with the class? Like, would you like to do more questions or should I end the class? Because Hamna has not joined and I was planning to start with a new chapter. So whatever you say. If you have any doubts, you can ask me that.
I don't have any doubts currently.
Sorry, I didn't hear.
I don't have any doubts currently.
Okay, okay. So Hamna, like, can we keep it half an hour class? Should I end now?
Okay.
Yeah. So I'll do one thing. I am going to share an assignment sheet with you today. So you can just do the questions on your own, and if you are having problem, then we can discuss them in the next class, right? So that will give you a practice for your exam also. So just please go through that. So like this, half the class will be counted today. So okay then. All right then, Rita. Good luck for your exam. Prepare well.
Thank you, ma'am.
Okay, bye.